Hello everyone. So in this lecture we will be doing examples from the exemplar of the chapter integration. So let's start with the first example. So our first question is integrate uh, 2a by root x minus b divided by x square plus 3c times cube root of x square. Okay. So let's write three integrals. So पहले इंटीग्रल में से 2a कॉमन ले लेते हैं. Then this is the integration of x की power minus half. In second integral, you can take minus b common. Then it is integral of x की power minus 2. In the third integral, you can take 3c common. And this is an integral of, let's remove the cube root also. So cube root remove करने के बाद this is x की power 2 by 3. And let's say dx. Okay. So let's write the integral now. So this is twice of a times. So x की power minus half का integral will be. So we'll add 1 here. So x की power half divided by half minus b times x की power minus 1 divided by minus 1 plus 3c times x की power 5 by 3 divided by 5 by 3 and plus some arbitrary constant, let's say k, because a b c are in use, so I will not say c, let's say c dash or k. And let's simplify this. So this is 4a times root x minus, so plus b by x, and then plus 9 by 5, so 9 by 5 times x की power 5 by 3 plus c. Okay, so now let's move to our next question. Okay, so let's continue. So in this question, let's see. First maybe we can take 3a common, and then our integral is like this, and probably we can take denominator as some variable z. So let's take b square plus c square x square as z, because its differentiation will be linear term of x, which is available in the numerator. So we get 0 plus c square into 2x is dz by dx. So, and we find x times dx is 1 by 2c square times dz. Okay, so x times dx can be replaced now in terms of dz, and we will use this and this equation as the substitution. So, okay, so our new integral becomes 3a, and denominator mein we will get z, and numerator mein I will get 1 by c square. So 2c square I will take outside into dz. So our result is 3a by 2c square into log mod z plus some k. So let's put the value of z now. So z was b square plus c square x square, which becomes our result. Okay, so let's move to our next question now. Okay, so in this problem, we could have integrated this, but it's saying verify the following using the concept of integration as an antiderivative. So we'll just take the derivative of the right hand side. So let's take that and simplify that result. So x minus x square by 2 plus x cube by 3 minus log mod x plus 1 plus c. So after taking the derivative, this is 1 minus 2x by 2 plus 3x square divided by 3 minus 1 by x plus 1 plus 0. So 2 cancels, 3 cancels. And let's take the LCM now. So if you can see, we have just these three terms and then this fraction. So we have to take the LCM. So which gives us the result. Denominator में x plus 1. 1 से multiply होगा x plus 1. So 1 into x plus 1. Then minus x into x plus 1. Plus x square into x plus 1. Minus 1. Okay. So simplifying this result. This is x plus 1. Okay. So simplifying this result, we get x plus 1 minus x square minus x plus x cube plus x square minus 1 divided by x plus 1. So इस x से ये x cancel हो गया. Let's change the color of the pen and show what else cancel. So इस 1 से ये 1 cancel हो गया and x square से x square cancel हो जाएगा. So what is left in the numerator is x cube. So this simplifies to x cube divided by x plus 1, which is the left hand side, right? So we have taken the antiderivative. So basically we have taken the so we have taken the derivative and shown integral is nothing but the antiderivative, right? Okay. So you can integrate the answer also. So let's move to our next question now. Okay, so in this problem, let's try to rationalize the given term first. So, well, you can rationalize like you can multiply with root of 1 minus x into root of 1 minus x like you used to do in class um, previous classes, so that you can remove the square root from the denominator, right? Okay. So but this will probably not help you, so this will not help you. Let's see. So in the numerator you will get root of 1 minus x square and denominator you will get root of 1 minus x, and after that uh, so if you have to do this question after that, we have you probably will not be able to proceed further. So what we have to do is actually multiply with root of 1 plus x in the numerator and denominator. So let's do that. So if I rationalize with 1 plus x in the numerator and denominator, so let's see, into root of 1 plus x divided by 1 plus x. So numerator will become 1 plus x and denominator will become root of 1 minus x square. And in this way, I can divide this root of 1 minus x square with 1 and x separately to write two integrals, right? Okay, this will simplify your result. So first one is simple. So and the second one you can just multiply and divide by 2. तो पहले वाले इंटीग्रल का रिजल्ट क्या होगा? So it's a straightforward result. जिसका आंसर है sin inverse x, right? ठीक है. And in the second one, if I have multiplied and divided by 2, and you can take 1 minus x square is equal to z, and minus 2x dx will be dz. So probably you will multiply with minus and minus also, right? And minus 2x dx is dz, and this integral will become minus half times root z, so dz divided by root z. So z की power minus half का integral, we can do that. So let's insert some space here. Okay, so z की power minus half का integral we can do as z की power half by half, so 2 root z, right? So 1 by root z का integral. So this is minus 1 by 2 into 2 root z plus c, and 2 and 2 cancels, and z की value is 1 minus x square. So we have the answer for this question also. Okay. So now let's move to our next problem. So this problem can be attempted in two ways. One way is you can do completing of the squares for the quadratic given in the denominator. And second way is you can take maybe x minus alpha as t square as given by the exemplar. लेट्स ट्राई मेथड वन. तो मेथड वन में आप क्या कर सकते हैं? यू कैन टेक दिस क्वाड्रेटिक and ये factorized है अभी, right? We don't need the factorized form. We need the form in which completing of the squares is done. So let's multiply all this. So we get beta x minus alpha. So minus x square. So let's multiply x first. Then alpha multiply करते हैं minus alpha beta plus alpha x. So I get let's take negative common. So x square and minus में alpha plus beta x plus alpha beta. And this is the factorized form for that. So negative हमने common लिया हो. And now let's do completing of the square. So CTS करेंगे. So x square and the second term here is minus twice of alpha plus beta by 2, right, into x. So what I will do is add alpha plus beta by 2 whole square and subtract alpha plus beta by 2 whole square, and these three terms will complete the square, right? And end may we have plus alpha beta, right? And this all is in the brackets. So first three terms give me x minus में alpha plus beta by 2, okay, and whole square, and minus में, well, we are getting alpha squared. So I'll use a bracket here, alpha square plus beta square plus 2 alpha beta divided by 4 and plus alpha beta. So let's take the LCM in the last two terms. So let's insert some space first. So this is x minus my alpha plus beta by 2 whole squared minus alpha square minus beta square minus 2 alpha beta, and if I take multiply and 4 there, so 4 alpha beta and divided by 4, and simplifying this we get x minus my alpha plus beta by 2 whole squared. And if I take negative common from all these terms in the bracket, I am getting alpha square plus beta square, and this is minus 2 alpha beta and plus 4, so plus 2 and negative common, so minus 2 alpha beta. Okay, so simplifying this further we get so thoda, let's bring it up. Okay, so negative x minus alpha plus beta by 2 whole square minus में alpha minus beta by 2 whole square, and this is alpha minus beta by 2 whole square minus में x minus alpha plus beta by 2 whole square. And if I write this in short form, let's see. So our integral, तो हम अब अपना integral लिख लेते हैं. So our integral which was let's see this one, right? Okay, will become so हमने इसी quadratic को हमने अब क्या किया, completing of the squares करके लिखा हुआ, right? This factorized quadratic is now written in completing of the squares form. So we'll just replace that quadratic. Oh, and we will get our integral as 1 by, and हमारा नया quadratic क्या है, अल्फा माइनस बीटा बाय 2 स्क्वायर माइनस में x माइनस में अल्फा प्लस बीटा बाय 2 होल स्क्वायर. तो रिमेंबर यहाँ पे ब्रैकेट है, दिस अल्फा प्लस बीटा है यहाँ पे, ठीक है. तो into dx. So probably you can do some substitution, right? Alpha minus beta by 2 को आप uh, let's say k डाल दीजिए, right? ठीक है. एंड x माइनस अल्फा प्लस बीटा बाई 2 को आप z डाल दीजिए. सो dx विल बी इक्वल टू dz, राइट? ठीक है. सो दिस इंटीग्रल कैन बी रिटन एज 1 बाय k रूट के अंदर k स्क्वायर माइनस z स्क्वायर, राइट? ठीक है, dz. एंड व्हाट इज द इंटीग्रल ऑफ दैट? तो 1 बाय a स्क्वायर माइनस x स्क्वायर का इंटीग्रेशन होता है साइन इनवर्स x बाय. सो this integral will be sin inverse z by k. Okay. So let's put the value of z and k जो हमने यहाँ राइट साइड पे सब्स्टिट्यूट किया था. So this will be sin inverse x माइनस में अल्फा प्लस बीटा बाय 2 divided by k which is alpha minus beta by 2 plus c. So which simplifies to sin inverse 2x minus alpha minus beta divided by alpha minus beta plus c. Okay. So this answer probably will not match with the answer given in the NCERT exemplar, because they have done the question in a different way and probably uh, unka answer twice of sine inverse and some different answer is inside. So okay, but inverse trigonometry, so you can prove that that result and this result are basically the same. Let's try this question with now method 2. Okay, so in this method we will do a simple substitution ki we will take one of the factors as t square. Okay? So let's take x minus alpha is equal to t square. So that will give you a substitution dx is equal to 2t dt. And ठीक है, x minus alpha की value तो है हमारे पास. So what is value of beta minus x? So we already know from this equation x is t square minus alpha. So from this you can imply beta minus x will be beta minus t square minus alpha, which is alpha plus beta minus t square. Okay, so we will use these equations and transform our this integral into 2t dt, and this factor will become t square and this factor will become alpha plus beta minus t square. So this t square when goes outside cancels with the t on the numerator and we are left with 2 dt divided by alpha plus beta minus t square, which is inside the square root. Okay, so this integral simplifies to 2 outside, and probably you can take alpha plus beta is equal to some k square, right? Okay, so some positive number. So k square minus t square, and now we can write the direct integral for this. So this is twice of sine inverse t by k plus c, and you can put the value of t. So t is square root of x minus a, and k can be written from this equation. K is square root of alpha minus beta. So if it is positive, right? Probably should is. So okay, so okay, we have made a small mistake, so let's correct that. So I'll highlight what we have done. So यहाँ पे this alpha when goes on the right side, this will become plus, and this is plus, and this is minus alpha, right? Okay. So probably you can say this is beta minus alpha minus t square. Okay. And I'll change the numbers accordingly now. So beta minus alpha, beta minus alpha, and I will do the substitution that let's say beta minus alpha is some k square. Okay. So beta minus alpha, and okay, now I'll just आखिरी स्टेप हमारा चेंज हो जाएगा कि k की वैल्यू क्या है, बीटा माइनस अल्फा. Okay, so which is the result given in the NCERT exemplar. Um, so which is twice of sine inverse root of x minus alpha divided by beta minus alpha plus c. Okay, and you can always prove that this result that we have just found now is equal. So you can do twice of sine inverse x, right? Okay. And you can use twice of sine inverse x की value, which is sine inverse 2x into root of 1 minus x square. Okay. So this is from inverse trigonometry. You can use that to verify that this result is equal to the previous result, which is this one, right? Okay. So let's move to our next problem now. Okay. So in this problem, we can maybe separate one secant square outside. So tan ki power 8x secant square x into secant square x dx. So this secant square x can be written in terms of tan. This is tan 8x into 1 plus tan square x into secant square x dx. So now maybe we can do a substitution. Tan x is equal to z. So secant square x into dx will be dz. So this integral will become z ki power 8 into 1 plus z square into dz. So first integral is z ki power 8 into dz. Second integral is z ki power 10 into dz. So which is z ki power 9 by 9 plus z ki power 11 by 11 plus c. But what was z? Z was tan x. So our result is tan x ki power 9 by 9 plus tan x ki power 11 by 11 plus c, which is the result in the exemplar also. So let's move to our next problem. Okay, so in this problem, if we look carefully in the denominator, we have a fourth order polynomial, but in which cubic and linear term are not there, right? So there are only even terms, zeroth power, quadratic power, and fourth power. So which is useful. Let's break our numerator into x square into x into dx. And denominator mein now we can see our substitution very clearly, right? So we can take x square is equal to z. So let's take x square is equal to z. So 2x dx will be dz. So x dx can be replaced with half of dz, right? Okay, half of dz. And x square की value कितनी डालनी? So x dx की जगह हमने डाला half dz. And x square की जगह let's put z, and denominator में we'll get a quadratic z square plus 3z plus 2. Okay. So now the question is from partial fractions, right? So let's see if we can factorize our denominator. So let's look at this quadratic z square plus 3z plus 2. So this can be written as z square plus 2z plus z plus 2. So this can be factorized. So z into z plus 2 plus 1 into z plus 2 z plus 1 into z plus 2. So this integral becomes z divided by z plus 1 into z plus 2. So numerator का power कम है denominator से, so we can use partial fractions. We don't have to do long division, right? So अगर ऊपर भी quadratic होता then we had to do long division, but right now we can just use partial fractions. So we can say z divided by z plus 1 into z plus 2 can be written as some a by z plus 1 plus b by z plus 2. So let's find a and b. So we find after taking the LCM a times z plus 2 plus b times z plus 1 is equal to z, and denominator में z plus 1 into z plus 2 cancel हो गया. So now from coefficient of z I can see from LHS which is 1. LHS में coefficient of z is 1. RHS में it is a plus b. And constant coefficient LHS में 0. There is no 1 or 2 there. Okay, RHS में this is twice of a plus b. So let's solve these equations. So this को subtract किया यहाँ से, so I find a is minus 1. So from these equations I find a is minus 1, and if a is minus 1, b is 2. Okay, so now we can use this particular equation and the value of a and b to convert our integral, and we can write our new integral as, so our new integral is a की value है minus 1 divided by z plus 1. So I'm using this one, right? And b, which is 2 divided by z plus 2. Okay, into dz. So let's insert some space here. So, and we find minus half outside and 1 by z plus 1 dz, and 2 cancels, 1 by z plus 2 dz. So minus half log mod z plus 1 plus log mod z plus 2 plus some constant, but z was x square, so our result is minus half log mod x square plus 1 plus में log x square mod x square plus 2. We don't require mod here or here because these terms are always positive, right? Okay, this term is always positive, so you can remove the mod also, right? Okay, plus c. So if you want to, you can combine the result just like the NCERT exemplar. So first log वाला term will become, so minus half जब अंदर आएगा तो उसका power minus half, and this will be 1 by square root of x square plus 1 plus log x square plus 2. तो जब log add होता है तो multiplication आएगा, so this is log x square plus 2 divided by square root of x square plus 1 plus c. Okay, which is same as the book. So let's move to our next problem now. Okay, in this problem we have a question like this: a times sine square x plus b times cos square x. So this is a standard question, right, in which you can divide numerator and denominator with cos square x to form something like secant square x dx, and denominator में a tan square x plus b, right? Okay. And you can take tan x is equal to z now. So there can be third term also. If you want to add a third term here, you can do that. In the denominator, there can be a third term type, like, which should be also quadratic, right? Sin x into cos x. Like. So and when we divide by cos square x, तो यहाँ पे बचेगा c tan x, right? Okay, even then you can take tan x is equal to z, right? And secant square x dx will be dz, and then denominator you will be left with the quadratic, which is a standard question. So let's do this question. So divide numerator and denominator with cos square x. So in the numerator we are left with secant square x. In denominator I'm left with 2 tan square x plus 5 into dx. So let's use tan x is equal to z now. So secant square x into dx is dz. So numerator में बचा dz and denominator में आ रहा twice of z square plus 5. So to do this question, what We can do, maybe we can take 2 common first. So let's take 2 common from the denominator, and this is z square plus 5 by 2, which is 5 by root 2. So 5 by 2, root of 5 by 2 whole square. So root of 5 by 2 whole square, right? And we can use the simple formula 1 by x square plus a square integral, which is 1 by a tan inverse x by a. So 1 by a, so 5 by 2 का square root, right? Okay, into tan inverse x by a, so z by 5 by 2 square root, so plus c, so which simplifies to 1 by root 10 into tan inverse z, and z was tan x, right? Okay, so tan x, and into root 2 divided by root 5 plus c. Okay, which is the same answer as the book. Yes, so let's move to next problem now. Okay, so in this problem we have to use limit of sums. So पहले आंसर कंफर्म कर लेते हैं इस क्वेश्चन का क्या है. So you can, अगर you can just do 7 times x square by 2 as the integral, right? Limits are -1 to 2, and -5 times dx का integral is -5x, -1 to 2, and we say 7 by 2 into 2 square minus में -1 square -5, 2 minus में -1, which is +1. So 7 by 2 into 3 minus, I get 15. So 21 by 2 minus 15. So our result must be 21 minus 30 by 2 minus 9 by 2. Okay. So let's find the answer using limit of sum. So what does limit of sum say? So limit of sum is used to find a definite integral from a to b fx dx, right? And it says the sum, so this result is b minus a into limit n approaching infinity 1 by n into f of a plus f of a plus h plus f of a plus 2h till f of a plus n minus 1 into h. So here we have to remember some condition, right? H is approaching to 0, n is approaching infinity, and h and n have a relation, right? That h is equal to b minus a by n, right? So this is the specific formula, which is nothing but we are adding all the thin strips to find the area under the curve, right? So using this formula, we can write now our integral, which is -1 to 2, so -1, right? So -1 to 2, 7x minus 5 dx can be written as b minus a, so which will be 2 minus my -1, so 2 plus 1, right? Limit n approaching infinity 1 by n into f of a. So this is our function, is our fx is, we know fx is 7x minus 5, right? Okay, so what is f of a? So our a is -1, right? So this is 7 into -1 plus, so -5, right? Then f of a plus h, so h is approaching to 0, but -1 plus h, so 7 into -1 plus h minus 5. Okay, and so on, so on, so on. Let's write the third term also. So 7 times -1 plus 2h, right? Okay. Minus 5, and so on, so on, so on till the last term, which is 7 plus में -1 plus में n-1 into h. So this one is in multiplication. So probably I'll just rub that off. So 7 into this. Okay. And -5 because our function is 7x minus 5. Okay, and bracket closed. Okay. So let's insert some space here and complete this. Okay. So now we have to solve a limit. So this is 3 and limit n tending to infinity 1 by n. So I'll collect different types of terms. So -5, -5, -5, right? So I have -5 common, 1 plus 1 plus 1, right? Plus 1. So this is n times, right? Okay. So now I also have -7, -7, -7. So I'll take -7 common, 1 plus 1 plus 1. And this is also n times, right? Okay. So but h starts from the second term, right? So h starts from the second term. And let's see what do we have with that. So so I have 7h here, twice of 7h here, thrice of 7h then. So I have 7 common, and then and probably I can take 7h common, right? 7h common. The first terms I am left. So second, so I have 0 plus 1 plus 2 till n minus 1, right? So these are all the terms in this series that we have. So okay, so these are n minus 1 terms. Because it starts from 0, you can neglect that. So these are, so 1 से लेकर n minus 1 तक, these are n minus 1 terms. Okay. So let's add this all up and find the result. We also have the relation between n and h, right? So from this equation, I can say h is b minus a, which is 3 by n, right? Okay. So I have these two equations, right? Okay. So 3 by n, of course, I can use for h ka value. Okay. So okay. So this result becomes 3 limit n tending to infinity. So 1 by n. So bracket my first term becomes -7n. Okay. Second term mein I can do 7 and h की जगह I can do 3 by n, right? ठीक है. And so I'm looking at this term, and 1 से लेकर n minus 1 तक का sum कितना होगा? तो first n natural numbers का sum होता है n into n plus 1 by 2. This will be n minus 1 into n minus 1 plus 1, which is n by 2. Summation r going from 1 to n, right? This is 1 plus 2 plus 3 till n, right? Okay. This is n into n plus 1 by 2. Special series from class 11th. And minus 5 times n, right? Okay. Okay. So let's cancel this n and this n and simplify the term inside. And probably we don't need to even. So this and this term becomes minus 12n. So 1 by n minus 12n. And this is plus 21 by 2 into n minus 1. So if you want to, you can simplify this term, but you can just divide by n now, because n tending to infinity may we divide by the highest power, right? So let's divide by n. So I find minus 12 plus 21 by 2 into 1 minus 1 by n. So now we can let go of in an n को हम infinity डालेंगे तो this term will drop to 0. So this will become 3 minus 12 plus 21 by 2 into 1 minus 0, right? So which simplifies our result to minus 12 plus 21 by 2, and this is 3 minus 24 plus 21 by 2, which is 3 into minus 3 by 2, which is minus 9 by 2, जो हमने पहले calculate करके रखा था, so that we can verify कि क्या answer आया, right? Okay, so let's move to our next problem now. Okay, to solve this problem we can use a simple property that 0 to a fx dx is same as 0 to a f of a minus x dx. So using that property we can say this integral is same as, so this, let's call this integral as I and let's call this as the first equation, right? And we can also write I as 0 to pi by 2 and tan 7 and pi by 2 minus x, right? Okay. Divided by cot 7th power pi by 2 minus x plus tan 7th pi by 2 minus x dx, and which forms our second equation 0 to pi by 2 cot 7x and denominator में tan 7x plus cot 7x. And if we notice for this equation 2 and 1, denominators are same and we can add them, so it's a simple NCERT question. So 1 plus 2, so you can find twice of I, which is equal to 0 to pi by 2, and if we add them numerator mein we will get tan 7x plus cot 7x divided by tan 7x plus cot 7x, which is the LCM, right? So these two cancel and we are just left with the integral of dx, whose integral is x, so limits are 0 to pi by 2. So I is half of pi by 2 minus 0, and we have our result for this question as pi by 4. Okay, so let's move to our next problem. Okay, to do such questions, so यहाँ पे either you can try to rationalize such questions, or you can use a property of definite integral ki a to b fx dx. So I will use this one. Okay, so it is same as a to b f of a plus b minus x dx, and अगर इससे नहीं हो रहा है then you can probably try to rationalize the denominator कि 1 by root x minus root y को आप rationalize कर दो root x plus root y से multiply करके, ठीक है? So if this does not help, try this, right? ठीक है? So probably we will be able to do this question using this formula. So let's apply this formula and let's call our original equation as 1, right? So I is this and this is the first equation. Now let's apply our formula. So I'm applying this because 2 plus 8 is 10, right? Which is in here, right? Okay, so I will become 2 to 8 and 10 minus, and हमें x की जगह क्या लिखना है? So x has to be replaced with, so if you notice in the formula you have to replace x with a plus b minus x, right? Okay, so x की जगह हमें क्या लिखना है? a plus b minus x, so which is 10 minus x. So x की जगह 10 minus x. Okay, x की जगह 10 minus x and प्लस में रूट ऑफ 10 माइनस में 10 minus x. So which gives us our second equation, which is root x divided by root of 10 minus x plus root x, and we can see in the first and the second equation denominators are same and we can add these two just like the previous question. So we get twice of I is equal to 0 to 2 to 8, and LCMs are same, so root x plus root of 10 minus x, and न्यूमरेटर में ऐड करने के बाद क्या आ रहा है, यही दोनों टर्म्स आ रहे हैं, ठीक है? and we can cancel these two. And twice of I is integral of x. Limits are 2 to 8. So I is half of 8 minus 2, which is 6 by 2, which is 3. Okay, so let's move to our next problem. Okay, so we have our next question. So 1 plus sine 2x is a standard formula which can be written as a complete square. So you can write sine 2x as twice of sine x into cos x, and 1 as sine square x plus cos square x. And this becomes sine x plus cos x whole square. And this integral now changes to 0 to pi by 4 square root of sine x plus cos x whole square dx. So just don't remove square and square root so बिना कुछ सोचे, right? ठीक है. If you remember, square root of a square of a number is mod of x, right? ठीक है. Because this LHS is positive, x चाहे यहाँ पे आप negative हो या positive, right? Even if you put -2, so -2 का square is 4 and square root of 4 is 2. So this is positive. So we get 0 to pi by 4 mod of sine x plus cos x, and our limits are between 0 to pi by 4. So 0 to pi by 4 कौन से में है? It's in first quadrant, right? ठीक है. So first quadrant में sin x and cos x are both positive, right? Okay, and this term is positive, so we can remove the modulus without any mistake, right? So since both are positive, I can just write it as a bracket, right? Sin x plus cos x. But अगर ये किसी और quadrant में होता तो probably यहाँ पे negative भी आ सकता था बाहर, right? ठीक है, so probably in third quadrant, right? If the question was in third quadrant, let's say pi से लेकर 5 pi by 4, then sin x was also negative, cos x was negative, their sum was negative, and then you have to apply the negative sign. So be careful, square root of x square is mod of x, so there will be a modulus here. So let's insert some space and complete this. So okay, so this question becomes 0 to pi by 4 sin x dx plus 0 to pi by 4 cos x dx. Sin x का इंटीग्रल होता है माइनस cos x, एंड cos x का इंटीग्रल होता है sin x. So cos pi by 4 minus cos 0 plus sin pi by 4 minus sin 0. So which simplifies our result. 1 by root 2 minus 1 plus में 1 by root 2 minus 0, and this is um, so minus 1 by root 2 and plus 1 by root 2 will probably cancel, and we are left with the answer as 1. Okay, so let's move to our next problem now. Okay, so this seems like a question from integration by parts. So we'll use the isolate. So our two functions are inverse trigonometric and algebraic, and this is the difficult side, right? Okay. And this is the easy side, and this is यहाँ पे हमारे पास कौन सा फंक्शन अवेलेबल है? इनवर्स ट्रिग्नोमेट्रिक में tan इनवर्स, right? यहाँ पे we have x square, and we will just take the difficult one outside, right? So u into v dx, you can take, let's say, u outside v dx minus du by dx into v dx, and we'll put a bracket and dx. So this is integration by parts. So इन दोनों में से डिफिकल्ट है tan inverse x, we will take it outside. Okay. Integration of x square dx minus d dx of tan inverse x into integration of x square dx, and we'll use a whole bracket into dx. So which is x cubed by 3 into tan inverse x minus 1 by 1 plus x square into x cubed by 3 dx. So x cubed by 3 tan inverse x minus 1 by 3 x cubed divided by 1 plus x square dx. So here we have to do long division. So let's do that here. कि 1 plus x, तो x square plus 1 को divide करते हैं. So sorry, x cube को divide करते हैं x square plus 1 से. So I'll multiply with x. So I'll get x cube plus x. So minus minus. So minus x is my LCM, and probably there is nothing more there. So so I have two integrals now. So अगर यहाँ पे हम divide करके लिखें, so there the terms are, so dividend is equal to divisor into quotient plus remainder. So this is x, and plus my remainder, so which is minus x divided by the x square plus 1. Okay. So which are two simple integrals. So let's insert some space in the below. So this is x cubed by 3 into tan inverse x minus 1/3 x dx plus 1/3, and इसमें I'll multiply with 2 also. So ऊपर I'll, so minus minus plus हो गया, and I'm multiplying with 2 because x square plus 1 का differentiation क्या होता है, 2x 3x होता है. So in this one I will do a substitution. X square plus 1 is equal to z, 2x dx is dz, and this integral will change as 1 by z dz, which is log mod z, and z की value कितनी है? So z is x square plus 1. So let's write our result now. So our result is x cubed by 3 tan inverse x minus 1 by 3 into x square by 2 minus x square by 6 plus 1 by 6 into log of x square plus 1 plus c. Okay. So let's move to our next problem now. Okay, so let's look at our quadratic here. So which is 4x square minus 4x plus 10. So let's do completing of the squares for this. So this is 2x whole square minus twice of 2x, and बाकी क्या बच रहा है 1. So let's add 1 square and subtract 1 square from this equation. So these three terms will form 2x minus 1 whole square minus 1 plus 10, which is plus 9. So 2x minus 1 square plus 9, which is 3 square, right? Okay, so this integral becomes square root के अंदर 2x minus 1 whole square plus 3 square dx. So probably I can take 2x minus 1 is equal to some t. So twice of x, so इसका differentiation is 2, which is dt by dx. So twice of dx is dt, and dx is half dt. So this integral becomes t square plus 3 square into half dt. So half let's take outside. So okay, now we need to write a simple integral of root of x square plus a square dx, right? Which is x by 2 root of x square plus a square plus में a square by 2 log of x plus में root of x square plus a square plus c. So just from NCERT, and let's complete this question now, and our result becomes half, and I'll use a bracket x by 2, so t by 2 into root of x square plus a square, so t square plus 3 square plus में a square, so which is 3 square divided by 2 log mod x, which is t, plus में t square plus 3 square plus c. So let's put back all the values. So this is t की value भी डाल देते, t की value is 2x minus 1, so this is 2x minus 1 divided by 4, and square root के अंदर आ रहा है 2x minus 1 whole square plus 3 square plus 9 by 4 log mod 2x minus 1 plus में square root के अंदर 2x minus 1 whole square plus 9, so plus 3 square, right? ठीक है, plus 3 square plus c. So you can leave the result as it is, or you already know कि इस quadratic को और इस quadratic को simplify करके क्या मिलेगा, वो हमने ऊपर ही किया था, right? ठीक है, so हमने completing of the squares किया था, but originally this quadratic was 4x square minus 4x plus 10, right? ठीक है, so you can also write the result as 2x minus 1 by 4 square root के अंदर 4x square minus 4x plus 10 4x square minus 4x plus 10. Okay, so let's move to our next problem now. Okay, so we have already seen a question like this. So here in the denominator we have a fourth order polynomial with cubic and linear terms missing. So we have only even terms, 0th power is quadratic, and so what we, but हमने last time क्या किया था, हमने हमारे पास ऊपर एक odd power था, right? Because then हमने substitution किया था, x square is equal to some z, right? 2x dx was dz, and but this time we will do this substitution only for the sake of the partial fraction. So let's write, ठीक है, let's say x square, क्योंकि ऊपर हमारे पास लीनियर टर्म नहीं है यहाँ पे सब्स्टिट्यूशन करने के लिए, so we will not use this. We'll just say x square is t just for the sake of the partial fraction. So this will become t. So let's forget about the dx and the integral, right? So let's just focus on the, okay, so let's forget about this integral, right? So we'll just focus on the this term, which is t square plus t minus 2, and this looks like something we can solve using partial fractions, right? Okay, we are doing this substitution only for partial fraction, right? Okay, only for partial fraction. So if we factorize the denominator, so plus 2t minus t, so t plus 2 into, so this is t square plus 2t minus t minus 2, t common t plus 2 minus 1 common t plus 2, so t minus 1 into t plus 2. So this partial fraction is t divided by t minus 1 into t plus 2, which we should be able to write as a by t minus 1 plus b by t plus 2, t plus 2. So let's find a and b. So when we take the LCM, we find a times t plus 2 plus b times t minus 1 is equal to t, and denominator वाले terms cancel over. So coefficient of t say I can find 1 is equal to a plus b, and constant coefficients I can find 0 is equal to 2a minus b. So let's add both of these. So 3a is 1. So from these two I can find 3a is 1 and a is 1 by 3. So if a is 1 by 3, we can always find from the first equation b is 2 by 3. So okay, so a is 1 by 3 and b is 2 by 3, and our this integral, so this integral now can be written as, so please use this one, right? Again, and a and b के value. So a is 1 by 3 and divided by t minus 1. So t क्या है but x square, right? So x square minus 1 plus 2 by 3 divided by x square plus 2. So t plus 2, right? So x square plus 2. So we have used x square is equal to t just for the partial fraction. And now our question is very, very simple. We can do it directly. So this is 1 by x square minus 1 into dx, 1 by 3 outside, right? Plus 2 by 3 outside, 1 by x square plus root 2 square, which are two direct formulas. So for first one, we find result as 1 by 2a, 2 into 1, log mod x minus a by x plus a. So x minus 1 by x plus 1 plus 2 by 3 into 1 by root 2 into tan inverse x by 2, x by root 2, right? And now, so we have our result as 1 by 6 log x minus 1 by x plus 1 plus root 2 by 3 tan inverse x by root 2 plus c. So let me check the answer from the book. Yeah, this is correct. So let's move to our next problem. Okay. Okay, so we have this important question. So this is a good question for school exam or any competitive exam. So so डिनोमिनेटर में x फोर्थ का डिफरेंशिएशन x क्यूब होता है, लेकिन एक एक्स्ट्रा टर्म है x, बट x स्क्वायर का डिफरेंशिएशन x होता है. सो कौन सा सब्स्टिट्यूशन करें? सो व्हाट वी विल डू इज राइट द टू इंटीग्रल. सो पहला इंटीग्रल लिखेंगे x क्यूब डिवाइडेड बाय x4 minus 9 dx, and second integral we'll write x divided by x4 minus 9 dx. In the first integral we will do a substitution. X की power 4 is equal to, let's say, uh, u, right? ठीक है. So we can find 4 times x cube dx is du. So x cube dx is 1/4 of du. So this is 1/4 du, and नीचे कितना आ रहा है? u minus 9. Okay. In the second integral, what you can do is take x square is equal to v, and 2x dx is dv, and x dx is half of dv, and integral will become half dv, and denominator में x square की जगह v डालना. So this is v square minus 9, which is 3 square. Okay, बीच में plus sign. So let's solve this further, and थोड़ा सा space insert भी कर देंगे if required. So okay, so first integral just becomes log of u minus 9, and second integral is 1 by 2 into 3 log of mod v minus 3 by v plus 3, right? Plus c. So first is 1 by x का integral, second is 1 by x square minus a square, which is 1 by 2a log of x minus a by x plus a, right? So Um, let's simplify all this to write our final result 1 by 4 log, but u की जगह हमें क्या लिखना है, x की power 4, and here I have 4 into 3 which is 12, and v की जगह लिखना है x square, which is the same result as the NCERT. So let's move to our next problem. Okay, so this is a good question for school exam. You will have to use the properties of definite integral and then simplify it using the properties of trigonometry. So let's use first the property 0 to a fx dx is same as 0 to a f of a minus x into dx. So this will change our integral into 0 to pi by 2, and sine of pi by 2 minus x is cos x, तो ऊपर बन जाएगा cos square x, and this will become cos x plus sin x. So denominators are basically same, right? So we'll take advantage of this. So यहाँ पे dx है, so I'll call this equation as 1 and this is I, right? So I is equal to this, and after applying this rule we have this as the uh, new equation, and we can add 1 plus 2 to find twice of I is nothing but 0 to pi by 2. Numerator में we will get sin square x plus cos square x divided by sin x plus cos x, right? So here numerator just becomes 1. Okay, so um okay, so numerator just becomes 1, so we can simplify this integral. I is equal to half of 0 to pi by 2 1 by sin x plus cos x. So sin x plus cos x, so you can divide by root 2 and multiply with root 2 to form a single trigonometric term, right? So let's say I multiply with root 2 and I divide by root 2, and let me call 1 by root 2 as sine as cos of, let's say, pi by 4. Okay, plus cos x into sine of pi by 4. Okay, so simplifying this, we have half and root 2 भी बाहर आ गया, 2 root 2, right? 0 to pi by 2, and denominator में sin a cos b plus cos a sin b, sin of a plus b. So sin of x plus pi by 4 dx, which becomes a simple integral of cosec x. So so I can be written as 1 by 2 root 2 0 to pi by 2 cosec x plus pi by 4 dx. So what is integration of cosec x dx? So it is log mod cosec x minus cot x, या फिर minus outside cosec x plus cot x. So I'll do cosec x minus cot x. Okay, so with this formula, we can simplify our result as 1 by 2 root 2 log mod cosec x plus pi by 4 minus cot x plus pi by 4 plus c. So, but our limits of this question are 0 to pi by 2. So let's put our limits in and find the result. So probably will require some more space here. So putting in the limits, we have 1 by 2 root 2. So pi by 2 डालने पे आ रहा है log of cosec 3 pi by 4 minus cot 3 pi by 4. Okay, minus the result which is at 0. So log mod cosec pi by 4 minus cot pi by 4. So I don't require C here, right? Because this is a question of definite integral, right? So I is 1 by 2 root 2. So second quadrant में cosec is positive. So this is root 2 and cot is negative. This is minus 1. So minus of minus 1 will become plus 1, right? And minus log first quadrant में this is root 2 and pi by 4 पे value 1 आती. So simplifying this further, we have 1 by 2 root 2 log of root 2 plus 1 divided by root 2 minus 1. And is this the answer? So probably we will have to rationalize it further. So let's rationalize this result to prove it that this is equal to the answer given in the book or the RHS. So 1 by 2 root 2 log. So this is root 2 plus 1 into root 2 plus 1 divided by root 2 minus 1 into root 2 plus 1. So I've multiplied and divided by root 2 plus 1. So न्यूमरेटर में आ रहा है रूट 2 प्लस 1 होल स्क्वायर, डिनोमिनेटर में आ रहा है 2 minus 1. So which is 1 and 2 can go outside because power can go outside. So this result will become 1 by root 2. So 2 bahar gaya, 2 and 2 cancel, and log of root 2 plus 1. And I can remove the modulus because this I already know root 2 plus 1 is positive. So which is the result given in the book also, right? Okay. So let's move to our next problem now. Okay, so this looks like a question of by parts. So I'll just calculate the indefinite integral first, which is x into tan inverse x whole square. And we'll put the limit 0 to 1 later, right? And we'll use integration by parts. U v dx is u v dx minus integration of du by dx into v dx integral and bracket and dx. Okay. And we know we have to take tan inverse x square outside because that is the, if we follow the islet, right? Okay. So take the difficult one, inverse trigonometric one, tan inverse x square, right? Outside, and keep the algebraic inside, right? Okay, which is x. So let's take this one outside, tan inverse x whole squared outside, integration of x dx, which is simple, minus d dx of tan inverse x whole squared, right? Okay. So into x dx and whole thing in the bracket dx. So this is tan inverse x squared into x square by 2 minus, so what is the differentiation of this? So tan inverse x square ka differentiation will be twice of tan inverse x. Then chain rule apply hoga, tan inverse x ka differentiation, which is 1 by 1 plus x square, into x square by 2 into dx. So this 2 and this 2 cancels. So we have tan inverse x squared. So probably I can just make one square here. So x into tan inverse x whole by ka square by 2 minus tan inverse x into x square by 1 plus x square dx. Okay. So अब इस प्रॉब्लम को कैसे सॉल्व करें? So again we will apply islet. ठीक है. So when we apply eyelet, second integral में tan inverse x will go outside, right? So let's put some space here. So okay. So let's do by parts again here, right? So this integral will become तो यहाँ पे इसको तो ऐसे ही छोड़ सकते हैं, and let's call it x minus tan inverse x whole square by 2, so x into minus I2, so let minus I, so I की वैल्यू अलग से निकाल लेते हैं. I is integral of tan inverse x into x square by 1 plus x square dx. तो यहाँ पे बाय पार्ट से करेंगे इसको, तो दिस tan inverse x can go outside. Integration of x square by 1 plus x square dx minus d dx of tan inverse x into integral of x square by 1 plus x square dx and whole thing in the bracket into dx. Okay, so this is the by parts for this. So if we notice, we are getting one integral twice, so let's calculate that one separately. So कौन सा integral है वो? So I'll call it I dash. So I dash, let's say, is integral of x square divided by 1 plus x square dx. So इसकी वैल्यू निकाल लेते हैं क्योंकि ये दो जगह आ रहा है, यहाँ आ रहा है, यहाँ आ रहा है. So I'll add 1 and subtract 1 in this one in the numerator. So I'll get 1 plus x square divided by 1 plus x square minus 1 dx. So this is 1 minus में 1 plus x square dx. So this is x minus tan inverse x. So this integral is nothing but, so this I is nothing but x minus में tan inverse x. So we'll put this value in both of those. Okay, so I dash, I dash, I dash, and I dash की वैल्यू डाल देते हैं. तो यहाँ पे वैल्यू डालनी है and यहाँ पे वैल्यू डालनी है, and we find I is nothing but, so blue से करते हैं. So tan inverse x into x minus tan inverse x minus, okay, so d dx of tan inverse x is 1 by 1 plus x square, and this integral is x minus tan inverse x. Okay, dx. So we have transformed this whole equation, right, into this equation, right? And let's look at our original equation also. Because, yeah. So let's just continue with this and let's complete this. So we'll see what happens to this. So this is x tan inverse x minus tan inverse x whole squared, and I can write two integrals. First is x by 1 plus x square dx, and then minus minus plus plus tan inverse x divided by 1 plus x square dx. So both of these can be solved very very easily, right? So let's give it some space, and अब I का वैल्यू कैलकुलेट कर लेते हैं फाइनली. तो पहला वाला इसमें इंटीग्रल निकालने के लिए we can multiply and divide by 2, and you can take 1 plus x square is equal to z. 2x dx will become dz, and 1 by, and this integral will become 2x dx की जगह dz आ जाएगा, and 1 plus x square की जगह z आ जाएगा. This will be integral of log mod z, right? ठीक है, I'll put it in a bracket, and यहाँ पे second integral में what you can do is uh, let's see, आप tan inverse x को z t ले लो रहे, ठीक है, so 1 by 1 plus x square into dx will be dt and this integral will become t dt, so t square by 2 will be the result, right? Okay. So our result will become I is x tan inverse x minus tan inverse x whole squared. So in the second one it will be minus half times log mod z, but z क्या था 1 plus x square, and last one is plus t square by 2, but t was tan inverse x, so tan inverse x squared by 2. Okay, so this I simplifies to x tan inverse x. So this term and the last term will give you minus tan inverse x by 2 square by 2 and minus half log mod 1 plus x square. Okay, now we can write our final result for this. We have our result was this minus I, right? Okay, so okay, so x tan inverse x का whole square divided by 2 minus I. So probably will require more space here. Okay, so final result, उस पर लिमिट्स भी लगाने हैं, ठीक है, रिजल्ट तो is x tan inverse x whole square divided by 2 minus I, तो माइनस में क्या आ रहा है x tan inverse x minus tan inverse x whole square divided by 2 minus half log mod 1 plus x square. तो एंड इस पूरे इंटीग्रल पे हमें लिमिट्स लगाने हैं 0 to 1, राइट? ठीक है, हमारा क्वेश्चन वो 0 to 1 में ये इंटीग्रल की वैल्यू कितनी है, तो quite a large result, but let's see. So प्लस हो जाएगा ये, राइट? And this will be also plus. So let's put 1 in this equation and we'll find 1 into tan inverse 1, which is pi by 4 का whole square divided by 2 minus 1 into pi by 4 plus pi by 4 का whole square divided by 2 plus half times log 1 plus 1, so which is 2. Then let's put 0 here. 0 डालने पे 0 into tan inverse 0, which is 0. ठीक है, minus 0 into 0 plus 0 by 2 plus half times log 1, and log 1 is also 0. Second term is this whole term is 0. Okay. So our result is pi square by 32 minus pi by 4 plus pi square by 32 plus half log 2. Okay, so let's just write the final result now. Okay, pi square by 32 plus pi square by 32 is pi square by 16 minus pi by 4 plus half log 2, which you can write log root 2, right? Okay. So half goes outside, so inside, and which is the same result as the exemplar. So if it is not visible, I'll just keep it up. Okay. So let's move to our next problem now. Okay, so in this problem, uh, we have critical points whenever the terms in the mod become 0. So x plus 1 कब 0 होगा? When x is minus 1, right? ठीक है. So, and mod x will be 0 when x is 0, and mod of x minus 1 can be 0 when x is 1. ठीक है. So these are the critical points. So I'll break the function at these points. So my fx will have new definition. So I will define it for in the region, let's say 3 है मेरे पास points, right? Minus 1, 0 and 1. So I will define it in 4 regions, 1, 2, 3 and 4th. Okay, so for x smaller than minus 1, okay, for x smaller than minus 1, um, uh, so you can see this will be negative, this will be negative, and this will be negative. So I'll multiply negative with each of them. So negative of x plus 1, negative x, and negative of x minus 1. And for x between, let's say minus 1 to 0. So in that case, the first term is positive, and the other terms, let's say अगर मैं कोई number put करूँ second वाले में, minus half put कर रहा हूँ, which is between minus 1 and 0. So this is negative, right? So I have to apply negative here. So minus x and minus of x minus 1. Okay. And in the fourth region, which is between 0 and 1. So first two terms are positive. So x plus 1 positive आएगा, x positive आएगा, but this term you have to multiply with negative to keep it positive, right? Okay. And the last region is for x greater than 1. For x greater than 1, our function is uh, x plus 1 plus x plus x minus 1. So our fx has a definition minus 3x minus 1 plus 1. Okay, so this is fine. Then in the second one, x and x cancel, and minus x plus 2. So minus x plus 2. Yeah. So minus x plus 2. So this is for x less than minus 1. This is between minus 1 से लेकर 0 के बीच में. Then let's say these two cancels plus 1. So this is x plus 2. And this is between 0 to 1. And for x greater than let's say equal to 1. So greater than equal to 1 के लिए our function is 3x. Okay. So now we can write our integral, which is minus 1 to 2 fx gx. So let's put some space here. So our question is minus 1 to 2 minus 1 to 2 fx gx. So minus 1 से मेरे को अब इसको कहाँ से ब्रेक करना है? minus 1 to 0 तक I have to write an integral, right? ठीक है. Then 0 से 1 में I have to write a different integral. And 1 से लेकर 2 के बीच में I have to write a different integral. So minus 1 to 0 के बीच में क्या है function की value? So this is the value, right? Okay. Then so I have to use this one, then this one, then this one, right? So minus 1 to 0 के बीच में value is minus x plus 2. 0 to 1 के बीच में answer is x plus 2. 1 से लेकर 2 के बीच में answer is 3x. So which is minus x square by 2 minus 1 to 0 plus 2x minus 1 to 0 plus x square by 2 0 to 1 plus 2x 0 to 1 plus 3x square by 2 1 to 2. So minus half outside, 0 minus 1, so 0 square minus में minus 1 का square, right? ठीक है, and plus 2, 0 minus में minus 1, so plus 1 plus half 1 square minus 0 square plus 2 1 minus 0 plus 3 by 2 2 square minus 1 square. So this is half negative negative positive, right? So plus 3, so plus 2, I'm sorry, plus half plus 2, so this is 3 into 3, which is 9 by 2. So this simplifies to 11 by 2 plus 4, which is 11 plus 8 by 2, and which is 19 by 2. Okay, so which is the same result as the exemplar. So we'll move to our next problem. Okay, so in this problem we can use the formula e to the power x into fx plus f dash x का integral is nothing but e की power x into fx plus some arbitrary constant c. So this is the by parts में करा था हमने, right? We can even prove this result. So but this is a result from the exercise integration by parts. ठीक है, हाँ. So let's see. So यहाँ पे किसको function लें किसको differentiation लें. So sin x का differentiation cos x होता है, cos x का differentiation minus sin x होता है. So okay, so this is already in the form, right? ठीक है, let's take fx is equal to cos x and f dash x will simply become minus sin x, right? Okay, and this integral is already in the form fx plus में f dash x, right? So the result must be e की power x into fx, which is cos x, plus c, and we find option A is the correct option, right? So let's move to our next problem. Okay, so in this problem, in denominator we have a fourth order polynomial in terms of sine and cos, but this is not a very difficult problem because we can replace the 1 in the numerator as, let's say, sine square x plus cos square x, right? And we can divide with the product in the denominator. So पहले वाले में sin square x cancel हो जाएगा, we'll be left with 1 by cos square x plus 1 by sin square x, so bracket dx, so which is the integral of secant square x dx plus में cos x square x dx. So secant square x का integration is simple, which is tan x. Cos x square x का integration is minus cot x, and we'll add an arbitrary constant, and that makes option C correct, right? So we'll move to our next problem now. Okay, so this question can be done using integration or by using differentiation because options ही check करने. So integration में what you can do, you can write numerator is equal to a times denominator plus b times differentiation of denominator. So I'm suggesting you can solve this question and then you have to find a and b by comparing coefficients. But so I suggest you can do this question. You can write the numerator, right? And you can decompose into a times denominator, which is 4 times e की power x plus 5 times e की power minus x plus b times differentiation of denominator, which is 4 times e की power x minus 5 times e की power minus x. So if you are able to find a and b, you should be able to solve this problem. But let's solve this question by just by differentiation. So RHS ले लेते हैं. Let's take ddx of the RHS, right? ठीक है. So ddx of RHS should be the, so I'm using the property key. I can differentiate the answer to find this result, right? So ax plus b times log 4ex plus 5 e की power minus x. So this is a into 1 plus b times log का differentiation, log x का differentiation 1 by x, so 4 e की power x plus 5 e की power minus x into chain rule से differentiation of the term inside, which is 4 e की power x minus 5 e की power minus x. Okay, so and this result should be equal to our the result given in the question, right? So antiderivative इसका it was 3 e की power x minus 5 e की power minus x divided by 4 e की power x plus 5 e की power minus x. So let's simplify the LHS and then just compare the coefficients. So if I take the LCM, I get a times 4 e की power x plus 5 e की power minus x plus b times 4 e की power x minus 5 e की power minus x divided by 4 e की power x plus 5 e की power minus x is equal to this result. So in the so we can cancel the denominator and we can compare the coefficients of e की power x and e की power minus x. So for example, e की power x के साथ में यहाँ पे क्या आ रहा है 4a plus 4b and यहाँ पे e की power minus x के साथ में क्या आ रहा है, so just 5a minus 5b and this is equal to 3 e की power x minus 5 e की power minus x. So comparing coefficients, we find 4a plus 4b is 3. This is from the e की power x का coefficients, right? Okay. And similarly, we can compare the coefficient of e की power minus x also to find 5b minus 5a minus 5b is 5 minus 5. Okay. So from this I find a plus b is 3 by 4 and from this I find a minus b is minus 1. Adding both of these equations to find 2a, which is minus 1 by 4, and I find a is minus 1 by 8. So we already know a plus b is 3 by 4. So a plus b is 3 by 4. A की value minus 1 by 8 डालेंगे. So we find b is 3 by 4 plus 1 by 8. So b is LCM 8. So 6 plus 1, 7. 7 by 8. Okay, so let's check which option is correct. So in our option, a must be minus 1 by 8 and b must be 7 by 8. A must be minus 1 by 8 and b must be 7 by 8. So looks like option A, right? Okay. Yeah. So book में इस question के लिए option C given है, which is wrong, and you can see option C and D basically say ठीक है जो भी है, but option C is not correct, right? Option A is correct. So book में option C given है, but the answer is minus 1 by 8 and 7 by 8. So option A is correct, right? Okay. So let's move to our next problem. Okay, so our question is now a plus c to b plus c into fx dx. इसको alternate form में लिखना है, क्या लिख सकते हैं इसको? So maybe we can use a substitution. So looking at a plus c and b plus c, I'm assuming, let's say I can write x is equal to some z plus c. So with now dx will be equal to dz, and when x is a plus c, then we know z की वैल्यू कितनी है, x minus c, right? ठीक है, z is x minus c, तो z की वैल्यू कितनी आएगी, a. And when x is let's say upper limit b plus c, then z, so b plus c minus c is b. Okay, so our this integral now can transform into a simple integral. So our limits now are for z are a to b, so a to b f of z plus c into dz. So you now using property 0, we can replace z with x. This will be a to b f of x plus c dx, x plus c dx. So which makes option B correct. And you can try using x minus c also and check अगर ये गलत आ रहा है, right? Option है, ठीक है. You can try x is equal to z minus c also. But okay, so I'll move to next problem now. Okay, so in this problem we are given some relations. The relations are f of x is equal to f of a minus x, and we are also given gx plus g of a minus x is equal to a. So for example, I can write gx plus, okay, so plus g of a minus x is equal to a. So these two things are given, right? Okay, and we have to evaluate this integral 0 to a fx into gx dx. So let's call this integral as I. So let's use our Queen's rule, which says 0 to a fx gx. So let's say some capital F, right? Is integral of 0 to a f of a minus x dx, right? Okay. So let's use this property to change this integral, and this integral will become 0 to a f of a minus x into g of a minus x into dx. And we have the values for both of them from equation 1 and 2, right? Okay. So from 1 and 2, f of a minus x की value कितनी है, fx है. G of a minus x is a minus gx, right? This is a minus gx. Now I can write I is equal to 0 to a times fx, so a goes outside fx, and the second integral is minus 0 to a fx into gx dx. And this one is the original integral I. So I is equal to, so a times 0 to a fx dx minus I. So we can now find the value of twice of I, and we can divide by 2. So twice of I is a times 0 to a fx dx, and I is a by 2 0 to a fx dx. So let's check our options. So looks like a by 2. Okay, looks like option B is correct. Okay, so now let's move to our next problem. Okay, so this is an important question from NCERT. So we are given, I'll make it a star. So we are given x is equal to 0 to y 1 by root of 1 plus 3t whole square dt. So one way to solve this question is to actually find the integral and then differentiate to find the results. So let's do that. So let's put 3t is equal to some let's say u. So 3 times dt is du, and dt is 1 by 3 du. And from this equation we can check when t is 0, u is 0, and when t is y, u is 3y. Okay, so x will be equal to 0 to 3y now, and I'll write 1 by 3 du and 1 by root of 1 plus u square, which is a simple integral. So which is log mod u plus root of 1 plus u square, and the limits are 0 to 3y. And then you will have to differentiate again it twice, right? Okay. Then you will have to differentiate this equation twice. जब हम limit put कर देंगे, you will get an equation in x and y. So this is 3y plus root of 1 plus 9y square and minus um, 0 डालने पे this is log of 0 plus root of 1 plus 0 square. So log 1 कितना होता है 0. This term will drop to 0. And we have x and y में relation. And then you differentiate it to find dx by dy, then dy by dx निकालो, and then उसको भी differentiate करो to find d2y by dx square. So this is a very long method. This seems like a very long method to solve this question, which is basically a MCQ question. So this is a, I'll suggest कि तो ठीक है, यहाँ पे आप कर सकते हो इसको, you can try it on your own कि um, so now you can find dx by dy, ठीक है, फिर उससे आप निकाल लेना dy by dx, then you can find d2y by dx square, and you're differentiating with respect to x, so do it carefully, ठीक है. So this is but a long method, right? Okay. So better will be if we had some formula to take the derivative of an integral, and actually we have one, and that is called the Newton-Leibniz formula. So and this one says if you have to take differentiation with respect to x of some integral of ft dt uh, from who has limits which are in terms of x, which are, let's say, phi x and psi x. So this is equal to f of psi x into psi dash x minus f of phi x into phi dash x. So very, very important formula for the point of view of JEE mains. It is very, very easy to prove also. But right now let's just apply this into this question and solve this. So this question is even then not short enough. Even then it is not short. But let's apply this and solve the question. So let's paste it here. Again, I'll say this is method 2. So what I will do, so यहाँ पे अगर मैं ध्यान से देखूँ, my limits now in this question are in terms of y. So I will differentiate this whole equation in terms of y. So यहाँ पे आप limits देखो, these are the functions of y, right? 0 and y, right? ठीक है. So differentiating with respect to y, and I can apply Newton-Leibniz formula to find dx by dy, which is, so same function, so 1 by root of 1 plus 9y square, and then differentiation of this function y, which is dy. Okay, which is basically 1, I'm sorry. So y ka differentiation is 1, right? Okay, with respect to y. So this is 1 minus 0 डालने पे फंक्शन की वैल्यू आ रही है 1/1 + 0 and then 0 का differentiation with respect to y is 0, so this term drops to 0, right? And so we find dx by dy is 1/1 plus 9y square. Okay, now we can find dy by dx. So dy by dx, which is root of 1 plus 9y square, and dy by dx 1 by square root x का differentiation is 1 by 2 square root of x, so 1 plus 9y square into, and then chain rule रहेगा 1 plus 9y square का differentiation is 0 plus 18y. Okay, into y. So okay, so I'm finding d2y by dx square now. I'm sorry, so I'm differentiating with respect to x. With respect to x I'm differentiating again. So I've applied square root of x का differentiation, which is 1 by 2 square root of x, and 1 plus 9y square का differentiation is 18y, and y का differentiation will be dy by dx also. Do not forget this term, right? Okay, so and dy by dx की वैल्यू हम कहाँ से लिखेंगे? From the previous equation. Okay, so let's put all these numbers in. So d2y by dx square is 9y divided by square root of 1 plus 9y square into square root of 1 plus 9y square, and these two cancels, and we find d2y by dx square किसके equal आ रहा है? This is equal to 9y. So let's check our options. So it is given equal to ay, तो a की value कितनी होगी? 9, right? Okay, that makes option C correct, and we can move to our next problem now. Okay, so this problem, there is a long way. The long method can be we from the values of mod, I can see mod x की value is plus x or minus x, right? Okay, for x greater than equal to 0 and for x less than 0. So I can break the integral from -1 to 0, and -1 to 0 में mod x की value minus x आएगी, right? Okay, and this is x cube divided by x square minus 2x plus 1 dx, and then 0 to 1 में mod x की value x आएगी, so x cube plus x plus 1 divided by x square plus 2x plus 1, and then you can solve this by long division and then 1 by quadratics, right? So this will be a standard NCERT problem. Okay? This is now a standard NCERT problem, but this is a long method. This is the long method. Okay? But this can be done using this way also, right? Okay? And there is another way to attempt this particular problem. So here, if we look at the denominator is a even function, x square plus twice of mod x plus 1. So let's see, if I take denominator, right, denominator as a function of x, which is x square plus twice of mod x plus 1. So and what is the value of denominator की minus x पे कितनी value आएगी? This is x square plus mod of minus x is also same as mod of x, right? So f of, so denominator is a even function, right? Dx is even function, right? Okay. So what I will do is split my numerator into even and odds. So यहाँ पे mod x and 1 are the even functions and x cube is the odd function. So that's a shorter method. So short method will be, I will just write -1 to 1 integral, but पहला किसका लिखूंगा? x cube, which is an odd function, divided by even function, right? X square plus twice of mod x plus 1. So this overall is a odd function, right? Okay. And second integral, so minus a to a odd function. So this integral must be 0, right? Okay, then minus 1 to 1 mod x plus 1, which is a even function, divided by x square plus twice of mod x plus 1, which is even. The whole of this function is a even function. So I can change my integral to only, I can do twice of the integral between 0 to 1, right? Okay. So minus a to a fx dx is equal to twice of 0 to a fx dx. So this is twice, so this is 0 plus twice of 0 to 1. And 0 to 1 में mod x की value कितनी होगी? X, right? So we can remove the mods also. And if we look at the denominator, this is particularly x plus 1 का whole square. So one of these terms can be eliminated now. So this is the integral of 1 by x plus 1 dx. So answer will be in terms of log. So this is twice of log mod x plus 1. Limits are 0 to 1. So this is twice of log 2. 1 डालने पे 2 आ रहा है, minus log 1. So log 1 is 0. And so answer is 2 log 2 or log 4, right? Okay. 2 goes outside, 2 square, right? So let's check our options. So 2 log 2, option B is the correct one. Right? So now let's move to our next problem. Okay, so in this question we are given an integral 0 to 1 e की power t divided by 1 plus t. It is given to be a and we have to find the same integral but नीचे क्या 1 by t square. So please remember 1 by t को अगर आप differentiate करते हो, let's say 1 by x को आप differentiate करते हो, right? Okay. You get minus 1 by x square. So अगर आपको denominator में square बनाना है तो you need to differentiate this term and we can differentiate this term if we apply by parts, but do not apply the isolate here. ठीक है? If you apply the isolate, you will probably take the exponential outside and keep the algebraic. Sorry, you will take the algebraic outside. ठीक है? तो ठीक है, let's apply isolate. So 1 by 1 plus t को will take outside and we'll keep this one inside because this is the easy side, right? Okay. So by parts apply करते and we get 0 to 1 okay 0 to 1. So maybe we'll ठीक है 0 to 1. So e to the power 1, so easier one we'll keep inside, difficult one we'll take outside, right? Okay, e to the power t inside dt and minus integral of ddt of 1 by 1 plus t integral of e की power t dt and dt and the limits on the second integral are also 0 to 1. So this integral is e to the power t, so e to the power t divided by 1 plus t, limits are 0 to 1, minus, so differentiation of this is minus 1 by 1 plus t square whole square, right, into e to the power t, which is this integral, into dt, and this whole thing is equal to a. Okay, and we have to find the term inside the second integral, right? So let's put the limits here. So 1 डालने पे आ रहा है e to the power 1 divided by 1 plus 1. 0 डालने पे आ रहा है e to the power 0 divided by 1 plus 0. Minus minus plus and this is the particular integral that we had to find, right? I. Okay. So we can say e by 2 minus 1 plus I is a, and from this we can say I is nothing but a plus 1 minus e by 2. So a plus 1 minus e by 2. So let's check which option is that. So this is option B, right? Okay. So option B is correct. So let's move to our next problem now. Okay, so in this question we have to do integral of some function which is like minus a to a and mod of fx, right? Okay, but now it doesn't matter if fx is even or odd, because mod fx is always a even function, right? Okay, mod fx is even, right? Okay, this is an even function. Um, um, Not particularly. But let's see at least for this one. So at least for this question, uh, it's not always even function, but if it is even or odd, it will be even. Okay, so let's see. Uh, so let's take our function is equal to mod of uh, x into cos pi x, right? Okay. And let's remove this one and let's find f of minus x. So f of minus x is nothing but mod of minus x into cos of, यहाँ पे माइनस डालेंगे तो माइनस पाई एक्स, cos of minus x is cos x, and mod में नेगेटिव का कुछ फर्क नहीं आएगा, right? This is negative x cos pi x and this is mod of x into cos pi x, right? Okay, which is same as fx. So this particular function is a even function and I can write this integral from minus 2 to 2 as twice of 0 to 2 and x into cos pi x. So this should be the first step of the question to simplify this. Okay. So next step of the question should be कि I should find the zeros of this function. So x into cos pi x is equal to 0 करते हैं. So I find x is equal to 0 or cos pi x is 0. So I find cos pi, so pi x should be odd multiples of pi by 2. So 2n plus 1, pi by 2. And x में pi cancel हो गए, तो x की वैल्यू आ रही है 2n plus 1 by 2. बट हमारे x के ऊपर लिमिट क्या है? सो अवर x is between 0 and 2. So let's find between 0 and 2 what are the values that we get. So n is equal to 0 पे I find x to be half. Minus 1 पे minus half आ रहा है, which is not between 0 and 2. And this is a critical point, and when n is 1, so I find 3 by 2, which is also between 0 and 2. Okay. So now I can split my integral into three integrals. So twice of. So my first integral, let's say, so yeah. So my first integral will be from. So यहाँ पे हमारा integral है 0 से लेकर 2 के बीच में. So as I've changed the integral, right? Minus 2 to 2 की जगह क्या था वो 0 to 2 था, right? ठीक है. So I'll just say 0 to half में मैं एक इंटीग्रल लिखूंगा, ठीक है, एंड अंदर फंक्शन के x इंटू कॉस ऑफ पाई एक्स मॉड के अंदर, देन हाफ से लेकर 3/2 x इंटू कॉस पाई एक्स dx प्लस 3/2 टू 2 x cos pi x dx. ओके, सो नाउ वी हैव टू डिसाइड द साइन कि कौन से वाले इंटीग्रल का साइन क्या आएगा. So let's increase the space here. Probably will require it. Okay. So between 0 and half, you can test if this is positive or negative, right? Okay, fx. Fx is, let's say, x into cos pi x. Let's find f of 1 by 4. This is 1 by 4 into cos pi by 4, which is positive. Okay. तो ये पॉजिटिव है, सो मॉड हटने पे दिस विल बी नॉट चेंज साइन. ओके, यहाँ पे हाफ से 3/2 के बीच में लेट्स फाइंड एफ ऑफ 1. दिस इज एक्स इंटू कॉस पाई. कॉस पाई is -1. This is x into -1, so this is negative. So I have to apply negative sign here in this region. And let's say 3/2 से लेकर 2 के बीच में. So so 3/2 से 2 के बीच में. So 3/2 plus 2/2 ले लेते हैं. So which is 7 pi by 4. Okay, so 7 by 4. So this is smaller than 2 and greater than 3/4. So this 7 by 4 into cos 7 pi by 4. So second quadrant में आ रहा है ये angle, and this cos 7 pi by 4 is negative, so this is negative. Second quadrant में cos is negative, and this is in sorry, second quadrant में नहीं है ये, fourth quadrant में. This is positive. So 7 by 4 into 1 by root 2. This is positive. This is in fourth quadrant. So my integrals are twice of 0 to half x into cos pi x dx, then minus, okay, so second one will be negative, half to 3/2 x into cos pi x dx, then positive 3/2 to 2 x into cos pi x dx. So it looks like we have to find the integral of x into cos pi x, and then we can just put in the limits here. So let's call that integral I and calculate that separately. So I is x into cos pi x dx. Let's use by parts and take x outside, cos pi x integral, minus sign ddx of x integral of cos pi x dx and whole dx, which is x cos pi x का integral is sin pi x by pi minus 1 into sin pi x by pi. So this is x into sin pi x by pi minus 1 by pi outside, and then sin pi x का integral, which is minus cos pi x by pi. So integral is x sin pi x divided by pi plus 1 by pi square into cos pi x. So let's put this in the three integrals. So and find our result. So this is twice of, so ये result use करेंगे, make sure. Let's put this. So half पे limit half डालने पे आएगा ये, half into sin pi by 2 divided by pi plus cos pi by 2 divided by pi square, and then 0 डालने पे this is half sin 0 divided by pi, so half नहीं, बाहर ये आएगा 0 into sin 0, and plus cos 0 divided by pi square. Okay, then next is negative of twice of, so 3/2 पे आ रहा है, 3/2 into sin 3 pi by 2 divided by pi plus cos 3 pi by 2 divided by pi square minus 0 डालने पे, सॉरी 0 नहीं, हाफ डालने पे, दिस इज हाफ sin pi by 2 divided by pi plus cos pi by 2 divided by pi square, bracket close, so plus twice, and limits are 2 and 3/2 this time, so this is twice of sin 2 pi divided by pi plus cos 2 pi divided by pi square. So I have put the value 2 here, and then 3/2 डालेंगे, 3/2 sin 3 pi by 2 divided by pi plus cos 3 pi by 2 divided by pi square. Okay, so lots and lots of terms. Let's find the result now. So let's make sure this is visible. So on simplification, this all results into twice, half into 1 by pi, so 1/2 pi. Cos pi by 2 is 0, so this term is 0. This term is 0. So let's write the zeros first. So odd multiples of pi by 2 cos में 0 होते हैं. So this term is 0. This term sin and pi पे 0 होता है. And this term is 0. Okay, so I've written all the zeros. Yeah, every term has 1 0 at least. So this is 1 by pi, and then minus cos 0 होता है 1, so minus 1 by pi square, minus twice of, ब्रैकेट के अंदर है sin 3 pi by 2 is -1, so minus 3 by 2 pi, so -1 आ रहा है, and so this term, right, and this one sin pi by 2 is 1, so this is minus 1 by 2 pi, and then plus 2 cos 2 pi is 1, so 1 by pi square. Sin 3 pi by 2 is -1, so which is minus 3 by 2 pi. Okay, so this is 1 by pi minus 2 by pi square plus, so this 2 cancel, and plus 3 by pi and this will also cancel, so minus minus plus, plus 1 by pi plus 2 by pi square, and 2 cancel, minus 3 by pi. So this term and this term goes away. Okay, so this term and this term, so should I cancel these? Is there a mistake? Let's see. So this term, right, 3 pi by 2 is -1, so this must be plus 3 by 2 pi. So minus and minus plus, so plus 3 by pi, and the result is 1 plus 1 plus 3 plus 3, 8 by pi, okay, which is same as the book. Okay, so let's move to our next problem now. Okay, so this question seems very simple. So this can be written as sine 6x by cos 6x into 1 by cos square x. So question converts into tan ki power 6x into secant square x. So you can take tan x is equal to z, secant square x dx will be dz, and the integral changes to z ki power 6 into dz, and which says our result is z की power 7 by 7, right? Okay, in a bracket plus c, and z कितना tan x, so this is tan की power 7x divided by 7 plus c. Okay, so let's move to our next problem. So made a mistake, हाँ, dx की जगह क्या आएगा, minus dt आएगा, so this is minus, so this is all positive, and so let's do it. So let's keep the negative inside for f. So mine and this minus and this minus can go here, right? Okay, and 0 to a fx dx. And since it's a odd function, negative of f of minus t will be minus of fx, and this is minus बाहर आएगा, तो this will be a to 0 ft dt. And then you can change the limits. So this will become 0 to a, right? This will become 0 to a ft dt with negative sign, and you can cancel both of these integrals, right? You can do x is equal to t's property zeros, and you can cancel this to find 0. Okay, so let's move to our next problem now. Okay, so this is also a property from NCERT. If 0 to 2a fx gx is equal to twice of 0 to a fx gx if f of 2a minus x is equal to fx. So fill in the blank था कर दिया, but proof is also very easy. So let's imagine हमें given है, ठीक है, given क्या है, f of 2a minus x dx, so sorry, f of 2a minus x is equal to fx, सिर्फ इतना given है. So using this, let's write our integral 0 to 2a fx dx. So I will break it at 0 to a fx dx. So this is the term we require, but second term को हम थोड़ा सा change कर देंगे. So a plus 2a f of x dx. तो इसमें हम क्या करेंगे, let's do a substitution. Let's put x is equal to 2a minus z, ठीक है, so that I can use 2a minus x as a function, right? So dx will be equal to minus dz when x is a. So when x is a, so we know from this equation z is 2a minus x, right? So when x is a, z is a, and when x is 2a, z is 0. So this becomes 0 to a fx dx. The first integral is remaining same, and second integral में we can change the limits now, right? a to t 2a की जगह क्या आएगा, a to 0 आएगा, right? ठीक है, a to 0 and f of 2a minus z into minus dz. But we already know from this given property that f of 2a minus z will be equal to fz. So let's use that. So this becomes 0 to a fx dx. Negative बाहर ले आते हैं, this negative, and a to 0, but this is fz dz, right? And when we swap the limits and when we change the limits, when we do it 0 to a, the negative sign will become positive. So So this will become 0 to a fx dx plus 0 to a fz dz. So you can put z is equal to x, dx is equal to dz, and this two will add up to become twice of 0 to a fx dx, which is the RHS. So हमने prove भी कर दिया इसे, right? And it was basically a fill in the blank. It was a property from NCERT. So now let's move to our next problem. Okay, so it's a very simple problem. You can take this integral to be I, and then you can apply the formula 0 to a. So 0 to a fx dx is same as, so basically Queen's rule is it is 0 to a f of a minus x dx, and I will also become 0 to pi by 2. I'll write it quickly. तो ऊपर जो साइन है that will become sine of pi by 2 minus x, so it will become cos की power n x, and नीचे I will have cos की power n x plus sine की power n x. So I'll mark this equation as 2 and previous one as 1. So you can add 1 and 2, so 1 plus 2, to find twice of I, which is equal to 0 to pi by 2 sine की power nx plus cos की power nx divided by sine की power nx plus cos की power nx. These two can cancel, and twice of I is integral of dx, which is x, and limits are 0 to pi by 2. And now for the last step, I is half of pi by 2 minus 0. So I is pi by 4. So इस वाले fill in the blank का आंसर है pi by 4. And we have done all the examples from the exemplar. In the next one, we will do the short questions, and in the next one, the long and the MCQs then. So hopefully you enjoyed this lecture. Make sure to like, share and subscribe. Notes will be available below the lecture. So thank you.